Number 27, a force in the negative direction of an x-axis is applied for 27 milliseconds to a 0.4 kilogram ball, initially moving at 40 meters per second in the positive direction of the axis. The force varies in magnitude and the impulse has magnitude of 32.4 newtons second. What are the ball's speed? Letter B, the direction of travel just after the force is applied. What are, letter C, the average magnitude of the force, and letter D, the direction of the impulse on the ball. So let's draw here what's happening. So we have our axis here. So let's say that to the right is the positive direction, and we know that initially the ball is moving in the positive direction of the axis. So let's say this is the ball over here, and it's moving to the right. We also know that is a force that is applied in the negative direction of the x-axis. So there is a force in this direction over here, right? So, and this force is not always the same. It's not constant. It varies in magnitude. The only thing that we know about the force is its direction and the impulse that the force causes and how long the force is applied, right? So let's write the data that we have here. So the mass of the ball is pretty easy, just write it down, 0.4 kilograms. We also know the speed of the ball, which is 40 meters per second, but we also know that it's moving to the right, so its velocity, its initial velocity, is equal to 14 meters per second. We also know that the force is applied for 27 times 10 to the minus 3 meters per second, seconds, because it's time, not meters per second. So 27 times 10 to the minus 3 seconds, because it is milliseconds over here, and milliseconds means 10 to the minus 3. So that's why we have 27 times 10 to the minus 3 seconds. We also know that the impulse is equal to 32.4 Newton seconds. Not Newton per second, it's Newton times second, right? Don't make this confusion over here. Okay, so let's analyze our problem over here and discuss the equations that we have to use. We know that the impulse is equal to the change in the momentum, but we also know that impulse is equal to the average force times the time that it is applied. So we have those two equations that we can work with. So let's think a little bit first, because we do know that the force points in the negative direction of the x-axis. So if the force is negative and at time it's positive, our impulse over here would be negative. So our impulse here is negative, right? So this is the first thing that we can notice by just analyzing the direction of the force. Okay, so now we can calculate what is the ball's speed and direction just after the force is applied. Okay, after the force is applied, we have this impulse over here, and the impulse is equal to the change in the momentum. And the change in the momentum can be write by mass times the change in the velocity, which by instance can be write by the final velocity minus the initial velocity. So the impulse is equal to mass times Vf minus Vi. And we want the final speed or velocity rather. So we just have to isolate it. So J divided by M is equal to Vf minus Vi. So Vf is equal to J over M plus Vi. Now we just have to replace the letters by the numbers, and we have that Vf is equal to minus 32.4 divided by 0.4 plus 14. And this gives us, let's see, this gives us minus 67 meters per second. So the answer for letter A is the speed, so the magnitude of this velocity over here. So the answer of letter A is just 67 meters per second. And the answer of letter B is the direction. It's to the left, right? To the left, or to the negative there. To the negative x direction. So that's the answer of letter B. Letter C, what are the average magnitude of the force? So we have the impulse and we have delta t. So we just have to use this equation over here. So we have the J is equal to the average force times delta t. So the average force is equal to J over delta t. And this is equal to minus 32.4 divided by 27 times 10 to the minus 3, which is equal to roughly 1.2 times 10 to the third newtons. Minus, right? Because it points in the negative direction. However, it wants the magnitude. So if you want the magnitude, just take the positive value of this number over here. Letter D, what is the direction of the impulse on the ball? We already discussed that, so it is negative over here, so it points to the negative direction. So that's it. Pretty easy, this problem over here.